Yeah, Edge, IoT, and 5G. I'm not, want to emphasize this isn't a solution, it's a set of questions. I want to start a discussion. I actually want to learn something from this. Hopefully, maybe you'll learn a little bit from me, but it's kind of the other way around, which is unusual, but you'll have to forgive me. So I'm genuinely asking a question here. A little bit of context so you understand why. I'm Tim Panton, I'm Steely Glint on Twitter. I'm the CTO at Pipe. And what Pipe does is provide a WebRTC toolkit to run on small IoT devices. So think cameras, that sort of thing, baby monitors. And the kind of magic is we built our own stack for that, for one thing. And then the other piece of magic is that we're decentralizing both the authentication and the security. So it's not a cloud-based centralized system. The authentication is pushed out to the edge, and you end up with end-to-end encryption between you and the device. And of course, it being WebRTC, you get free NAT traversal as well. So it doesn't care that the device is behind, you know, a DSL router or whatever. And you end up with a pipe between a camera and your smartphone. So the typical use is like a baby monitor, because those users care about privacy for their babies, which is why this is kind of interesting for them. And what's interesting about this and where we differ from the typical WebRTC use case is the users are almost always in the same building. The primary user of the camera is typically in the same building as the camera itself. And that differs from your classic video conferencing use case, where the other user is across the world. Now, there's a lot of talk about 5G being a replacement for Wi-Fi or substituting for Wi-Fi in some cases. And when you look at these, a lot of the use cases they talk about require quite low latency. This exemplifies almost all of those things. This is DJI's farming package. So it's a drone with specialized cameras for looking at how your plants are doing. And it comes with mapping software, and you bring your own device to it, and you fly it around your 150-hectare field. So what's interesting about that is it's bring your own device, because they're expecting you to bring your own Android or iOS for it. It's geographically local. You're going to fly it around your own farm, but it's a big area. It's quite hard to cover with Wi-Fi. I mean, DJI kind of use the fact that you can directionally point your piloting box at the thing, and they have an antenna that's directional. But in general, it's quite difficult to cover a whole field with something like Wi-Fi. So it is an interesting use case for 5G. And like I said before, this use case is quite different from a classic video conferencing use case, but it shares some of the same things in that it's video over low latency, real time. So I was thinking about this in the context of what we do at Pipe, and I was thinking, well, it would be interesting to find out how this plays out. So I cheated, and I'm going to cheat twice actually here. So I did an experiment, which is to make a call from one phone to another over WebRTC. And you see there you've got a 0.2 of a second, 0.179 second latency between the two ends. That's if you do it over LTE. And then if you do the same thing over Wi-Fi, you get 0.008 second latency. And you look at that and you think, what? They're literally, I'm just going to do this demo, but there's not actually enough signal down here to do it, which is why I popped upstairs to grab these screenshots. But what's interesting is that you can have two phones that are physically next to each other on the same network and still get nearly 200 milliseconds of latency between them, in contrast to your 10 milliseconds or less on Wi-Fi. So you ask yourself, how can that possibly be the case? How insane is that? Well, the answer is that what happens is your your data goes up to the telco core network, through the cell, up to the core network, out to the internet, down through the internet to a turn server, which is a kind of standard component in WebRTC, back up to the internet, across to the telco network, down to the cell, and back down to the handset, which is probably 10 yards away from the device. Right? And all of that obviously adds latency. And if you look at where the desired path is, you can see why. So that's the 4G situation, and I'm pretty convinced that the 5G situation will be the same. Now, I'm happy to be told why that's not true, but let's just kind of get to the end. And you ask yourself why that situation happens. And the answer is that there are 4 horsemen in every opco that you have to deal with and who will block any innovation. This is copyright of this guy, by the way, but you know, billing, legal intercept, spectrum policy, and 3GPP standards will guarantee to block any innovation that you come in with. And you know, you basically, that's why that path is the way it is, and you kind of have to work around that. And no, I don't believe that SDN software-defined networks won't help in 5G. And the reason is that if you ask yourself how the farmer, how they're going to add themselves to actually the correct term is a slice, not a layer, but how they're going to get to be part of an SDN slice just for the video relationship with their drone and not for their e-commerce. Like, how are you going to get there, bring their own device for the 1 hour a week that they fly the drone to suddenly become part of the SDN and not send emails and updates over it, right? I don't believe that scales with the current designs. Again, happy to be told I'm wrong, happy to be told why I'm wrong. But what if you take the turn server that was sitting here and you run it in the cell? If you could move that into the cell, then you could keep the latency down to the absolute minimum, like the radio latency. And it turns out the turn request has pretty much what you need to do that. It's got a set of credentials, which are somewhat configurable in the sense that they can be both long-term or short-term credentials. You've got a target IP address, which has been allocated by the core network, so the core network knows what it is and who it's associated with. And that might be V6 in a lot of networks these days. It's got and by the way, all of this stuff works nicely in V6 as well. It's got the source IP address as well, so it knows a lot of stuff. It knows the terminal, so it kind of knows how the channels come in. In theory, the cell knows the radio channel it came in on, so it knows enough to know exactly which terminal's involved. And you'd think that that might well be enough to permission setting up a turn service. Don't know enough about the 5G standards to know whether that's plausible or not, but it feels to me like it ought to be. So how might that work? Well, as far as the app is concerned, the thing that's sitting in the DJI application that you install on your iOS device, all it needs to do is to add an extra line of configuration which says, and by the way, here's a new turn server that may be associated with the network. And the apps just send a turn request. And if it gets ignored, it doesn't matter. Like the structure of turn is that you throw, like the whole startup for WebRTC is you just basically spray packets around all of the possible directions that might work. And you find a pairing that works, and that's your connection. So if you add an extra turn server that doesn't work for some reason, it actually doesn't matter. It just costs you a couple of packets. And that will create you a temporary path. The call turn server sees that, and it sets up a temporary path somehow. Now, I'm a little vague about exactly how that would be. It could either be literally a turn server running in the cell, or it could do something funky with the network. It could set up change the firewall rules on the network. It could change the NATing rules on the network. It could spin up a baby SDN. I don't know. But it seems to me that that would be possible to do somehow, and that's kind of the heart of my question is, am I right that this is possible? How impossible is it? And then what you get out of that, if you could do it, would be you get low latency, and it will work with 2.5 billion smartphones. The thing with WebRTC and Turn is that it's in every smartphone. Every smartphone under 3 years old has a working WebRTC in the browser, zero install. So this stuff isn't like, you don't have to install it, you don't have to add it, it's all there already in every smartphone. Apple and Google are doing this for you. You don't have to do anything. And the pipe, the end of this connection, terminates, and this is a subtle point, it's kind of important, terminates at the application layer, not at the OS layer. What that means is that side connection you've created doesn't offer itself for sending email or downloading porn or whatever else is happening on the device. It only goes application to application layer. The OS doesn't see it as a separate IP route, which is kind of interesting for a bunch of use cases, I think. The other things, like standard stuff, really WebRTC attributes, like it's an IETF W3C standard. Like, it's not like we're making up cryptography here. This isn't new stuff. There's tons of deployment of it out there already. And like I said before, if it doesn't work, if this Turn server doesn't work, well, it'll just fall over to use the old one, the external one that's sitting on the internet, and you'll get your 200 millisecond latency. So you haven't actually lost anything. All right, I know, it won't happen, right? The four horsemen will stop us. And this is probably true, right? But, because it might happen in private 5G networks. It's the only place where you could realistically think it might happen. And there are, those places they're typically aiming at places that own the land. So it's a warehouse, it's a factory, it's a distribution yard. It's somewhere with, or a farm, or potentially a village with a not spot. I think there's an interesting set of politics around villages with not spots, where the parish council puts up a cell. Islands, I know of a few islands who have very, very poor internet connectivity, and to call the idea of making a connection across the island going through the satellite uplink is just insane. And then you've got the whole kind of temporary sites. There's another classic thing for private networks. Things like festivals, camping sites, things like that, which are seasonal. You want to drag a quick tower in, run it for a few weeks, and then switch it off. And in those areas, the four horsemen don't have quite as much control. Politically and in other ways, they're not as strong in those spaces. And I think that's the only place where I think it might realistically be possible. And you get a bunch of side benefits, right? In those places, typically those places with terrible backhaul, right? These are exactly the places where you want to keep the traffic local because you don't have backhaul off island or you don't have backhaul off farm. And guess what? It works when you've got a cloud outage, right? Because it's stayed local. Your data traffic is staying local, so it carries on working. It opens up, and one of the horsemen won't think this is an opportunity, but I do. It opens up a set of interesting billing models. You can start billing by something other than the megabyte. You could start billing by hectares. Like if you could have a farm package that you sell with DJI that says, we bill you by the hectare of coverage. And we don't care how many tractors you have or when you use them. I think whether that works or not, I don't know, but it's interesting. And then this is a kind of GDPR. The last two are kind of GDPR commercial secrecy points. But if you talk to some of the German industrial IoT companies, they are really, really horrified. The idea that their aggregate their machine learning data is being shipped out of the company and is being amalgamated with their competitors' data, and their competitors' machines are being tuned with data that's come out of their production line. They run their production line better, and somebody else's production line, which is using maybe some of the same equipment or some of the same Amazon services, suddenly gets better. They don't like that. They want the data to stay local. So this is a way of guaranteeing that as well. And then on the personal side, you get the same sort of thing that, like in Europe, it's getting expensive to collect data which you don't need. If you start collecting personal data which you don't genuinely need, you've got a downstream legal cost which is going to be big. Now, how big? Unknowable, but it's a risk. So my ask is, having listened to all that, if anyone wants to try building this with me, I would love to collaborate. Or the other ask is, tell me why I'm wrong. Tell me why this is a bad idea. Tell me why this won't work. Tell me, yeah, either here or in the bar or by email, somehow, because I really would like to know.
Excellent. Thank you so much, Tim. Andre.
You said it should work for Ireland, so I think it should work for Britain as well.
Yeah, we haven't cut the connection yet, but it won't be long.
Any other questions?
Just a comment. Jonathan was here yesterday. He's working with Andy Smith, and they're basically working on this. I'm not sure if they're adding to it into it. It's probably a good idea to put these together with that.
Oh yeah, tell it. So James Bowden.
Yeah.
Yeah. So he knows James Bowden. It's a small
Work with that.
community.
They'll work here.
So I think it would be interesting to kind of find out why I'm wrong, because I feel like there must be a reason.
You're probably wrong, but we might be able to work something out. So let's
Cool.
Let's hook up and then we can have a discussion on this.
Great.
Excellent. That's great. Thank you again, Tim. It's good that you're able to connect.